Hello, everybody, and welcome to this session. My name is Federica Ciuffo. I'm Italian, but I live in Spain, in Madrid. So happy to see you all here today with us. And today with me is also Sai Venom.
Hey everyone, Sai here. I'm a container specialist at AWS. I'm based out of Austin, Texas, but originally I'm from India, and excited to talk to you guys about networking strategies for Kubernetes today. This is a 400-level talk, but I'll just give you a quick heads up that we're going to start at smaller levels of complexity and kind of build up as we get to the end of the session. Let's go ahead and get started.
Yeah. And actually, we have built the agenda with all the interactions that we have with customers during this 2024. As we are both container specialists, we have a lot of conversation around Kubernetes networking. And so we wanted to highlight the most interesting customer interaction that we had during the year, and also the most asked questions. And to make this session a little bit more interactive, we have translated those customer questions and topics into requirements of an application. This will be the rental store application. And today, we will do a little bit of role play, Sai and I. So I will be a cloud architect who is responsible of architecting the cloud and also Kubernetes clusters to run this application, while Sai?
Yeah, I'm going to be the cluster operator, right? So I can say that with most of the people that I've talked to at sessions today, I'm guessing a lot of you in the audience today are on a platform team at your company operating Kubernetes clusters. And I hope to kind of emulate that role today. So Federica is going to give me requirements. She's going to come from a position of being a really well-versed cloud architect. And she's going to be giving me demands that I have to fulfill as the platform team. So that's kind of the back and forth we're going to try to do.
Yeah, so we put our hats on.
All right.
And so Sai, we have different requirements for our application. The first thing that I want to do is actually to simplify your life and make it easier to simplify cluster operations. So let's streamline that as much as possible. As well as our application is an external application, so our customer will be able to actually access it externally. So we will see how to do that together. And we also need we want to improve the resiliency in general, in particular of the network, but also based on the findings that we find, we also want to be able to observe this architecture and this application at each time in a way that doesn't really burden my application teams, which are, spending a lot of time into observing, but without a really clear way of how to do so with many microservices. We also have some requirements from security teams, so we need to enforce that. And we want to be able to take a different approach as to tackle those disruptions within the cluster when we make new updates, for example. For example, we have to update the cluster each 3 months and things like this. So all of these operations that can be disruptive, right now we are doing it with the in-place upgrades, etc. But we want to have a deeper look into something that could be a little bit less disruptive, like blue-greens, in that sense. But before diving deeper into that, I think, Sai, I already sent you the application. So if we can take a look.
Yeah, let's take a look at the application really quickly here. So I'm going to switch this to my computer here. And as a heads up, OK, that's the wrong screen that's being shared there. So give us just 1 second. Let's see what's going on here.
Yeah. So in the meantime, let's review what we want to do in that sense. But let me review how we are gonna deploy the application and where it actually will live, while Sai reviews where he has the application. So in that sense, our organization has different business units. And each business unit has a dedicated account. Also, we have some on-premises data centers that we need to take into consideration, and everything is actually connected with transit gateway. There is also, well, some direct connects and etc. for the environments. So I think we got the application, right?
Yes, we got it. Perfect timing. All right. Excellent. So let me make this a little bit bigger. So we were saying that we had the local version of the application up and running. So Federica's team has basically built containers on their local machines. And to do so, they've built a version of this retail store sample application that runs locally without running on the cloud. And let's just see what that looks like by running a quick command here to start up the application. All right. We're going to set the MySQL password to pass, and then do a Docker compose up. And I think this is a great way to work with containers locally. You can see what it did there was download the container images, and what it's doing is it's starting up the application now locally. And in a few seconds here, it's fully started. And let's actually go to our local host here to access the application. Boom, there we go. This is our beautiful retail store sample application running locally. But while this is great for development, it kind of enables iterative development very quickly with containers on your local machine. We need a way to run this in the cloud, right?
Yeah.
So that's kind of the next step here.
Yeah, exactly. And actually what we will need is to have a replica of this application in each and every VPC and environment that is dedicated to the retail account. The application that Sai just showed is made up of different decoupled components, and we have some infrastructure dependencies. We have seen the MySQL there. And so let's go right into it. The first thing that we want to do is to simplify your life. And actually, thinking about the Kubernetes architecture, there are a lot of networking components that we need to configure and take into consideration. Not only the control plane and the different components that talk to each other, but also how are we gonna bring together control plane and data plane. Within the data plane also some very core networking components that we need to take into consideration, and our cluster needs to be configured with that to be able to use those. For example, we have kube proxy, core DNS, the CNI, so a lot of things, and we want to simplify that. And this is actually where Amazon EKS can help. Sai, do you want to take this one?
Yeah, absolutely. So let's talk a little bit about Amazon EKS. And you guys might be wondering, Sai, this is a networking talk. Why are we talking about EKS? Believe me, I'm getting to it. So Amazon EKS is really just managed Kubernetes. It's not our special version of Kubernetes. It's open source, upstream, conformant Kubernetes that we help manage for you. Now, when we first launched Amazon EKS, about 6 years ago now, the focus was on helping customers by managing the control plane. So you kind of saw there with that very neat animation, the capabilities that we're managing for you with the control plane. But we're taking this a step further. And I think all of you know what I'm about to talk about here, but it was the announcement that we released just earlier this week. Now, Amazon EKS is helping customers manage parts of the data plane as well. So essentially, what AutoMode enables customers to do is have EKS clusters that are ready for production use cases out of the box. All of these components that you as platform teams, me as a platform operator, had to manage on my own are now managed for you. And the scope and the purview of AutoMode is, is continuing to increase. You can check out the roadmap. It's a lot of it is public on GitHub. And so critically, so where AutoMode fits in with networking is that a number of key networking components are managed for you in AutoMode. Let's dive into these really quickly. For one, the VPC CNI is going to be managed for you now. So this is the one that's by default set up with every EKS cluster, but no longer managed by you in your data plane. We handle it for you. That means when you upgrade your control plane, those add-ons are upgraded for you as well. This means less cognitive overload of managing different components of your data plane. In addition, core DNS out of the box, as well as KUB proxy, these are all going to be kind of managed for you. In fact, there's actually one more thing here that's going to be managed for you, the application load balancer controller as well, which will be coming out of the box with all EKS auto mode clusters. So put all of that together, and essentially what you have is Amazon EKS managing more capabilities for you in the control plane and data plane. But Federica, you've looked into a little bit about CNIs. Can you explain your requirements and why you want to use this CNI versus maybe some other ones?
Yeah, exactly. So we are going for the Amazon VPC CNI, actually, because it simplifies a bit how can we do Kubernetes within AWS. Effectively, the Amazon VPC CNI, it's deeply integrated with the underlying network that is Amazon VPC. And thus, it assigns IPs from Amazon VPC to pods. And this is great for us because it enables us to take advantage of all the good things of Amazon VPC. Like, for example, we can do security, we can do also observability with VPC flow logs. Also, the CNI is highly customizable. That is, we can really fit the CNI and change all the specs to our needs. And this is great for us. Also, we need to consider there are other alternate CNIs that are compatible with RKS, but not supported. What does this mean? That it is recommended to have support from the vendor of the CNI of your choice. But we are going to stick with this CNI, and actually, I love how all of these, well, Amazon EKS, then on top of that, auto mode helps your life and your team to really streamline and take that heavy lifting out of your team, and let AWS handle this.
Yeah, I'm glad that you're okay with using the VPC CNI, because that makes my life easier. It's integrated into the AWS ecosystem as a platform team. Less things for me to worry about managing.
And actually, you mentioned before about load balancer controller. So this is actually tied to our next requirement. And our next requirement, I want my customers to be able to access my application. Now, great what Sai just showed us that he was running locally, but this is not what we need. So we need something more. And when we are thinking about how to access application from outside the cluster to our backend pods, we always need some Kubernetes objects, that is ingress and service resources. Ingress resources operating at the layer 7 application layer, and service resources operating at the network transport layer. But we need something more. We need some infrastructure piece that help us to let that, let's say, traffic from outside the cluster inside the cluster. And that piece usually is a proxy, a load balancer. So in AWS, there is a native way to do so by using the AWS load balancer controller. And I am very excited about the capabilities of AWS load balancer controller because, again, I want to simplify my team's work with operating with Kubernetes on AWS. The AWS load balancer controller automatically deploys an application load balancer with ingress resources, and a service with service resources, it automatically deploys a network load balancer. So native AWS load balancers that actually have all the built-in reliability, scalability, etc. But in particular, not only so supporting in auto mode as we were saying before, but in particular I want to dive deeper into what it can do for us at layer 7. Because if you think about it, we are actually using an application load balancer. The application load balancer itself is a layer 7 load balancer. So what does this mean? So all the capabilities, all the layer 7 processing happens at a load balancer layer. That is, can be offloaded from the configuration that your application teams and my application teams need to do to the load balancer. For example, certificates. It can be offloaded to the load balancer, and then it can also be managed by AWS certificate management, so it's certificate manager, that it is actually deeply integrated with AWS load balancer controller itself. And we can take advantage of all those integration between the AWS load balancer and the security and network suite within AWS. And this is great for us because it simplifies our life. Additionally, there is another way you could, deploy or handle ingress traffic, that is use a third-party ingress controller. You can see here that now the processing, the layer 7 processing and features shifts from being a responsibility of the load balancer to being the responsibility of the controller itself. And this is key because, for example, where before we could offload SSL certificate management to the load balancer, now we need to supply that to the ingress controller. And this is essentially very different. Another thing that is different and adds a little bit more management is that you are handling only ingress resources. So if you need to handle service resources, you will need an additional controller, a service controller. With AKS, this used to be very transparent to do with the entry load balancer controller or service controller. But that has not gone away. It's still there, but we are only pushing, let's say, updates. There are essential security updates to it. So what it is actually recommended, again, for handling the service deployment of load balancers is, again, the AWS load balancer controller. Funny enough, if you're using an ingress controller, you will still need the AWS load balancer controller to deploy the load balancer that is in front of the ingress controller of your choice. So, we have gone through the differences and what we can do with the AWS load balancer controller, third-party controllers, but can we see it in action with my application? That would be amazing.
Let's do it. So we're going to get into our first kind of real demo, that Docker Compose one. Not a real demo, really, but here we're going to jump into actually exposing an application using an application load balancer. That's layer 7 based load balancing. And just very quickly, I want to say here that I love this diagram because you can kind of see how, when you create an ingress resource, obviously it gives you more advanced path-based routing that operates at the layer 7 level. You can create those with custom ingress controllers or the AWS load balancer controller. And at the layer 4 level, if you want to get a load balance for each individual service, you can do so with the network load balancers that are also kind of, you can create with the AWS load balancer controller. All right, so let's go ahead and get into this. So in my EKS cluster here, we've basically deployed all of, I can tell the internet connection is already a little bit. We're going to get all the pods in the cluster, but in this cluster, we've already deployed the containers for the retail sample application that we have today. And critically, you can see here that we've also deployed the AWS load balancer controller. By the way, if you were to run this command in an auto mode cluster, you wouldn't see those pods because the load balancer controller is managed for you. But since I'm running on a standard cluster, not auto mode, this is something that I had to install myself. And then obviously, when I upgrade the cluster, I would also have to handle upgrading the load balancer controller itself. OK, once that controller is installed, essentially what Kubernetes is now able to do is anytime an ingress resource is created or a service with the type load balancer, the controller kicks in. It says, oh, I know what to do now. And in the back end, it's going to start creating resources for us in AWS. And it's deeply integrated, right? A lot of things happening, especially if you're doing custom domains and you have certs and that kind of thing. There's a lot going on in the back end with Route 53 and ACM, certificate authority, and all of that that the load balancer controller will handle for you. So I did create an ingress resource. So I'm going to run get ingress in all namespaces. And there we go. We can see fairly straightforward here that we have an ingress. It has an address. We'll copy it and access it. But before I do that, I do want to quickly show you what's in that ingress YAML. And this is really critical here to understand how specifying an ingress works, because you can kind of see a few things here. Notably, there's annotations. And these tell the application load balancer controller, ALB, that we're creating for this ingress, something that's internet facing, not internal only. So we want public internet access for this. We want the target type to be IP mode, and the other option is instance mode. I won't get into this in too much depth right now, but I'll share some resources for how you can dive deeper into the reason why we provide both options. In addition, a health check path so that the target group knows whether it's healthy or not. And then the other critical piece here is the service it's actually routing to, right? So if I do a quick get service in the UI namespace, what I'll see is the UI service here, port 80, and that's essentially what we're routing to with that ingress. Okay, last thing I want to call out here, because I've gotten this question a lot this week. The question is, with auto mode, do you have to do anything special to use the AWS managed version of the load balancer controller versus the one that's just running in your cluster with non-auto mode clusters? And by the way, since you can add auto mode to your existing clusters, this is critical for how you're going to migrate to the AWS managed version of the controller. Essentially, you'll notice here there's an ingress class name. So when you want to use the auto mode managed version of the controller, essentially what you'll do is you'll create a new ingress class that specifies that you want ingress resources to be handled by that controller instead. This makes it really seamless for you to migrate clusters to auto mode, because you simply need to install that new ingress class and then switch the kind of ingresses that you have to the new ingress class, and then you can remove the load balancer controller from your cluster. You no longer need to manage it. Okay, now that we've seen all that, I'm going to pray a little bit to the demo gods of the internet. It's all work. Actually, that loaded perfectly fast. Thank you. So you can see here that the application running in the cloud in Kubernetes, fronted by an ingress resource, so application load balancing. All right, guys, I promise you we're starting at a lower level of complexity, and we're going to bump it up as we kind of go through the presentation. So with this demo, I'm going to pass it back to you, Federica, and let's get into some more fun stuff.
PowerPoint. Yeah. And actually, thank you, because this is our first requirements. Again, we wanted to start simple for my teams that are adopting Kubernetes clusters with Amazon EKS. And there are a lot of things that you can also do with adding certificates to this domain, etc. So thank you, Sai, for showing us how we can do this. But we have other requirements. So let's see this. So with my teams, we have a lot of problems when it comes to network resiliency, because as long as we are already following all the best practices, spreading pods across availability zones with topology spread constraints, we are also deploying a lot of reliability built-in mechanisms within the applications. But for us, it is really difficult to test disaster recovery scenarios. So one thing that can help us to do that is actually the new integration of Amazon EKS with ARC, Amazon Recovery Controller. And this makes it easy for us to test and recover from a disaster recovery scenario, because we don't have to wait for the health checks on the services to fail. But actually, the ARC controller will signal that the AZ is down, and the targets, the endpoints that are in the affected zone will automatically be deregistered from the service. And this is great for us.
I've got to ask. So I don't know what ARC is just yet, so you got to tell me, why do we need ARC when the whole reason we're using Kubernetes is because when pods are unhealthy, they automatically stop getting traffic routed to them. So what's the point of using ARC?
The problem is that there is a delay to it. So we need to wait for those health checks to fail, and then the targets will be deregistered. That will be a lot of problems. So ARC shortened that time, because it automatically in AWS API, they signals that as soon as there is an easy, let's say, failure, and this is automatically done. It is true that my team responsibility will also be to make that application resilient.
Okay, so essentially, while Kubernetes could detect that the pods are unhealthy and stop routing traffic to it, it takes a little while because essentially the health check has to fail, the readiness probes, the health probes, and then it happens. So this could impact your customers. But here, essentially we're improving availability by making it a little bit faster, where the second there's an AZ issue, we'll just zonal shift that traffic, right?
Correct.
Awesome.
And also, it's very interesting for us, the thing that we can test those scenarios, even if there isn't a real AZ failure. So, about testing the scenarios, I mentioned that my teams actually have built a lot on the application to ensure reliability. And it has been a long work, because first you need to observe where bottlenecks or potential failures are. Then you need to implement it within the application. Then there is application A that is using an application coding language, programming language. Another with another programming language. So it's kind of a mess for us. And I was looking from an architectural perspective for a way for us to unify those operations and take that burden away from my application teams. So maybe in the ecosystem, the most used way to do so is adopting service meshes. And real quick, what's a service mesh? So in the most common architecture for service mesh, you take a proxy, you put it next to your application containers. You do that for each application container within the cluster, and you create basically a new layer that is made up of all of those proxies, and you push to that layer the advanced networking, network security, and network observability responsibility. Thus, you are decoupling that from the application business logic that still will be handled by the developers to those other things that are now unified with only one programming language, because you will be using that actually proxy for each and every application. So it makes my life easier, makes my application life easier, and it is very powerful. If you look at the capabilities and what service meshes bring to us, all of the things that we want to do are actually there. We want to be able to observe, for example, tracing requests, understand what bottlenecks are, and then we want to be able to implement those reliability features, not within the application, but within the service mesh. Also a security feature to it. I have a lot of requests from my security team around, for example, mutual TLS and securing the workloads, etc. So that's a really big ask. Although, service meshes also come with some challenges.
Right. Federica, I love the fact that you covered all the advantages, but you're kind of leaving out the part of me as the operator having to manage all the challenges of running a service mesh. And traditionally, the kind of service meshes we're talking about here, things like Istio that work off of the sidecar model, right? And so the challenges, well, some of them are going to be things like resource efficiency issues, right? So when sidecars are not being utilized to max efficiency, or the fact that sidecars need to scale up with every pod as they scale up, this can be challenging. In addition, just installing the sidecars into a cluster is not so easy. It requires the pods be restarted, because every time you add the sidecar, the pod needs to go through a restart cycle. That's not great either. In addition, additional points of failure, security boundaries, these are all things that, as the platform team, I need to be thinking about. And of course, I do want to implement organizational best practices at the same time, because as the platform team, I've been told all service-to-service communication has to be encrypted, has to go over mutual TLS. So we need some solution. So I like the idea of using a service mesh, because Federica's team doesn't have to instrument each single application with all of the things that we need for observability, security. We can add it as a layer on top, which removes complexity from her team, adds a little bit to mine. But I think we have an approach to this: Istio ambient mesh. So essentially, Istio ambient mesh, what it's going to do is enable us to get the same advantages of Istio in a traditional sidecar model, but without the sidecars. And the way it does this is by essentially encrypting traffic between services into a Z-tunnel proxy. This particular protocol that it uses, it's an Istio-specific term called HBone. HTTP-based overlay network environment. So when you break that apart, it's not that complicated. It's an environment that overlays on top of your network, and it's based on HTTP. And the interesting thing about this is that essentially what it'll do is make it so that all of the traffic going between your services now goes through this Z tunnel. That enables us to have mutual TLS out of the box. No pods need to be restarted. The traffic goes from working at a network layer, working in your network, to going through the Z tunnel, right? So that happens as a kind of switch that flips. And to show that, I want to actually jump to a demo. And by the way, I know that you saw a bit about waypoint proxies as well. I'll get to that in a second. That's for layer 7 capabilities. We're going to focus on layer 4. That's IP addresses, layer 4 authorization. Think IPs and ports rather than fully qualified domain names, paths, domains, that kind of thing. OK, so let's take a look at my cluster environment. I'm going to use K9s. And if you don't use this, I highly recommend it. It's a great way to step through your cluster, see what's running, that kind of thing. And in this cluster, oh yeah, the internet's a little bit slow here, but there we go. We can see that I've already installed Istio. Now this is a non-disruptive activity, by the way. It's kind of like a Helm chart. You just install into the cluster, these pods get started. And you can see that it comes with some observability tools like Grafana, Prometheus, Kiali, Jaeger, and the control plane for Istio as well as an ingress gateway for how traffic gets routed through Istio instead. OK, and you can see that, yeah, these pods haven't been restarted actually in the last 26 days. And so real quick, let's take a look. There's a helpful command that Istio Cuddle exposes for us called ztunnel config workloads. And this is all the workloads in our cluster. And we can see that right now, that protocol is TCP. And that essentially telling us it's not going over the HBone protocol. We don't have that mutual TLS enabled just yet. And to enable that, we simply need to, this is really cool in my opinion, label the default namespace with this annotation, just with this label rather. We set the data plane mode to ambient. And that's it. Now the traffic is going to start going through the HBone proxy. So we'll run that Istio Cuddle command again. And there we go. Now all those workloads that were TCP before are now going over the HBone protocol. You can ignore these. These are some admin control plane type services. Those don't need to be changed. But for our actual application workloads, they're going over HBone. And let me just get the services real quick so I can access it. I'm going to grab the one for the Istio ingress gateway. Apologize, it's a little hard to read, but I'm just going to grab the Istio piece. And so remember, our applications weren't restarted. I need to do a couple of cacherless reloads here just to hit the application here. But there we go. We can access our application. Pod-to-pod communication is happening with mutual TLS. No downtime, no pod restarts. We have ambient mesh enabled in our cluster. But when we think about Istio, we don't just use Istio for mutual TLS. That seems like a bit of an overkill. We get a lot of other advantages with Istio as well, right? So observability is one of the critical ones. So I would love to show you how to enable observability capabilities as well. So very quickly, just jumping back to the slides here. With ztunnel, we have this mutual TLS out of the box. We have layer 4 authorization policies that we can implement as well. Istio is great for the layer 7 capabilities, right? So more advanced traffic routing and that kind of thing. So with a waypoint, essentially what we do is we have traffic that now goes through the separate waypoint that's running on the cluster. And this is what's going to give Istio the ability to do layer 7 capabilities and really rich observability. In fact, we're also going to do a demo of chaos engineering here in a minute. Another popular use case for why you would want this waypoint for layer 7 capabilities is canary deployments. Let's say you have a new feature that you want to roll out to a subset of your users, maybe users on Firefox or users on a mobile phone. All of that becomes just a flip that we can switch at the network layer. The app teams don't need to necessarily change any code. We can do that at the network layer, that overlay layer. It's really powerful stuff. Let's take a look at what that looks like. We're going to jump back to my machine here. And to enable the waypoint, let me make this a little bit easier for you all to see. OK. To apply the waypoint, essentially what I'll do is run this Istio Cuddle helper command that applies a waypoint in the default namespace. And that's it. Again, no pods are restarting because this just starts a new pod. And we'll get deployments in the cluster. And we can see that we, 7 seconds ago, started this new waypoint. And now we should have observability in our application. I'm just going to refresh this a couple times to make sure we have some logs, metrics kind of flowing through the application and that kind of thing. Maybe we'll add a pocket watch to our card, and we'll hit the checkout button. OK, awesome. That should be enough. Now we're going to go back to our command line and run handy Istio cuddle dashboard Kiali. Kiali is an open source kind of observability tool helping us see exactly how our application looks. Let's make sure we're looking at like the last 3 hours of data. OK, that's really hard to read. That's not very interesting to me. So let me start cleaning this up a bit. So I'm going to hide the unknown nodes. I want an app graph. I'm going to go here. Oh, already looking better. I'm going to go here. I'm going to enable some of these things here. I'm going to get rid of service nodes. I'm going to do traffic animations, waypoint proxies, and there we go. So you can already see a lot more that we can see here. Let's disable TCP traffic because I don't want to see like Prometheus stuff going on. And boom, there we go. We can now see kind of a visual layout of our application architecture. I didn't complete a checkout, so that's why this line is black, because we don't have mutual TLS for this pod, because I didn't actually do a checkout process. But you can see right here that it's showing traffic for the other pods that were activated when I was clicking around in the sample application. Click into one of these, and you can see that the traffic from UI to carts has mutual TLS enabled. So pretty cool stuff in my opinion. In fact, I can even jump into things like carts and see exactly what application is talking to what. And I might notice here that, hey, one of my services is talking to a service that it shouldn't. And I could use Istio to implement an authorization or network policy to prevent access between services that maybe shouldn't be talking to one another, right? Limiting blast radius, implementing better security practices. OK, so what did we see here? We saw with Istio ambient mesh, without ever restarting any of our pods, any of our applications, we got layer 4 capabilities, mutual TLS enabled, and we were able to get some great observability out of this as well. I mentioned I wanted to do a chaos engineering demo for you, so let's talk about that real quick. So in the gateway that I deployed into this cluster, which is really straightforward, I'm basically, it's kind of like that ingress resource that I showed earlier. It's just the Istio way of doing it. I exposed the UI service. And for that UI service, let's insert a fault. So about 75% of the time, it's going to fail. And I haven't applied this yet, so let's just make sure I'm still hitting the application. Yep, all is good. But now, let's apply this new gateway. It should say configured the virtual service. There you go, configured. And now, 75% of the time, this should fail. Boom. All right, so we hit that fault already. This is really chaos engineering at its finest. It's seeing how your application would respond to failures. So we could also do things like maybe implement a retry policy on failure and see if our application responds correctly. Let's keep hitting this a few times, because 25% of the time it should work. Wow, that's crazy. I should not go gambling today. All right, that took 7 times for it to actually work. And we can already see that there's some issues with the cache invalidation that's going on. So I feel like we already uncovered a bug, right? So maybe when there's a fault, we should deal with the cache a little better so users don't end up seeing a page like this. Really?
Something for my teams to think about.
Exactly, exactly. So what do you think, Federica? Oops, we don't need that. Let's jump to the slides.
Yeah. I think this is exactly what we are looking for, actually, Sai. So thank you for showing that. I love the fact that really easily we can have mutual TLS in the cluster. That's a very big ask from security teams, etc. So definitely also I like all the things that we can do in terms of observability and implementing new things that will enhance the reliability of our applications with Istio ambient. But I also want to put you on the spot here. So is there any limitation that we should be aware about for Istio ambient?
So there is a limitation here. When we first started implementing ambient mesh with this application, what we saw was that one of the services didn't mesh well with ambient mode. No pun intended. Essentially, what we saw was that one of the pods uses the MySQL protocol to access our persistence layer. And that protocol didn't play nicely with the Z tunnel. So it's like, well, what do we do here? Well, there's a really great thing that we can do, which shows kind of the flexibility of ambient mesh. Essentially, what we did, and I'll pull up K9s again here, my terminal UI, and dig into that catalog deployment. And I did cheat here a little bit. And you'll notice that in this pod, we have 2 containers running. And just to show you what that second container is, it's an Envoy proxy. There we go. So essentially what we've done for just this catalog service is enable a sidecar. And so yes, for this pod, I had to restart it. And you might have noticed when I ran that ztunnel config workloads command first, there was one service that was already on the HBone protocol. That was my little cheat. So beforehand, I'd set up that pod already with the sidecar. And so that really shows how flexible ambient mesh can be for certain workloads that don't work on that HBone protocol, that ztunnel proxy. Essentially, what you do is in the deployment configuration for just that one catalog service, right? That catalog service, we add this label, sidecar injection is true. And so for that one pod, we have a sidecar. And in fact, in Kiali, it showed it as well, that for that one pod, we had a sidecar enabled. And I think we can even show that really quickly here. Going here. OK. Let's reset this back to what it was before. All right, here we go. So looking at the catalog, that little icon right there, that tells us that it had a sidecar in it. So OK, awesome. We saw how for certain workloads that maybe don't work great with that ztunnel proxy, we can just stick a sidecar on it and get going.
Amazing, thank you. And this is exactly what we look for. And also, I like that for my teams, including you, we can go from a no service mesh state to a, let's say, secure layer service mesh state to a fully fledged one without needing to adopt the full layer 7 capabilities right away. So that's amazing as well. And also, I wanted to circle back a little bit. We talked a lot about ingresses before. And actually, ingresses, well, are great, but those are limited. Ingresses are limited. To do advanced network stuff with ingress, you need to do a lot of annotations, custom resource definitions. So, and actually, the Kubernetes ecosystem is not adding new features to ingress. So this will be the same also going forward. The evolution, though, of ingress, that is the Kubernetes Gateway API, has all those capabilities. And all the new features are added to the Kubernetes Gateway API. The Gateway API tries to solve all of the challenges that you had with ingresses and takes all the lessons learned from service meshes. And fun enough, this Gateway API is the one that we are using for the layer 7 Istio ambient. So the ecosystem, in general, is going for a rapid adoption towards the Kubernetes Gateway API. Finally, we have one API that everybody can use so that we don't have, when we want to move from, for example, a service mesh to the other, or an ingress specification to the other, we needed to, like, for example, for the ingress controllers, many different annotations. The migration to one ingress controller to the other was very difficult. Now, with the Gateway API, since we have the same spec, this will be easier. So, other things that you can do with the Gateway API. First of all, you can do all that you could do with the ingress API, obviously. So you can handle ingress traffic, but you can also handle, and you can obviously do more. All of that you could do with the annotations. Now it's embedded within the API again. Then you can do service to service with the Gamma project. And now in the last KubeCon, we also have seen applications of the Kubernetes Gateway API for egress traffic. So that's amazing because we have one API to handle all these use cases and scenario and to unify Kubernetes networking, really. Another thing that's a specific topic that you can also tackle with Kubernetes Gateway API that I wanted to dive deeper is actually blue-green scenarios across clusters. So, for example, as I explained before, my teams are spending a lot of time in doing cluster upgrades, for example. And we are doing the in-place upgrades right now. But we wanted to explore how it would look like to do blue-greens, for example, for better reliability. We want to be able to roll back if needed. We want to do canary deployments to the new versions. So all of these things. And looking at the ecosystem, we said, OK, we need to do multi-cluster then. Which are the options for us? We have adopted the Istio ambient, but multi-cluster is still not supported for Istio ambient. And in general, thinking about how you approach multi-cluster with Istio or a service mesh in general, well, there are multiple considerations that we need to do as architects. For example, we need to think about how we are going to set up the control plane. Are we going to externalize the control plane to manage the clusters? Are we going to set it up in a high availability mode? Other things that we need to consider is that we need to share API permissions across the clusters. Then there is encryption and tenancy boundaries. Then again, we also need to take care of trust between meshes. So if it was difficult before to start with service meshes, adding multiple clusters to the mesh adds a very big layer of complexity to it. So I told you that this can be also done with the Kubernetes Gateway API. So a different approach is using the Kubernetes Gateway API, and you do that coupling it with another set of APIs, two APIs in general, that are the multi-cluster services API, service import and service export, that enable you to do that, let's say, multi-cluster that we need, but in an easier way, with a Kubernetes native way. And within AWS, we do implement the Kubernetes Gateway API and the multi-cluster services API with Amazon VPC Lattice as infrastructure. So, like for example, we have seen before the ingress with the ingress controller that implemented load balancers. Now we see the Kubernetes Gateway API with its controller that implements Amazon VPC Lattice resources. And real quick, what Amazon VPC Lattice is. So, first of all, Amazon VPC Lattice is a network service, just like Transit Gateway, just like VPC peering, but it operates at a different layer, the layer 7 of the OC model, unlike Transit Gateway, unlike VPC peering. And it enables us to connect applications across VPCs and accounts without the need of those services, just by using Amazon VPC Lattice. Also implements an AWS native approach to security. And another nice thing is that not only can we have traffic across multiple clusters using the Kubernetes Gateway API and Amazon VPC Lattice, but also with Amazon VPC Lattice, you could have a single URL that sends some part of the traffic to, let's say, a service within Amazon EC2, and a service that is either in Kubernetes or, for example, ECS or Lambda. And this is very compelling to us because we also have some, well, legacy workloads still running on EC2 that we would like to modernize. And there is effectively many challenges, but networking is one of them. So this simplifies for that a lot for us.
Yeah, absolutely. We're really excited about the Gateway API. It's really this thing that the whole community and cloud providers are kind of centering around. Of course, the Gateway API is an open source upstream Kubernetes thing, right? Like the evolution of ingress. And so cloud providers, especially like AWS, are creating controllers like the Gateway API controller that Federica covered on the past slide to be able to implement some of those resources in AWS. And VPC Lattice really hooks into that really nicely with that Gateway API controller. So instead of creating ingresses and kind of ingress APIs and services, it's kind of a new approach with gateways and HTTP routes. And I think we're really going to see the community and customers kind of move to this new approach because of the number of advantages that it offers. That one that I'll say SLA is being able to route to targets outside of the cluster, whether it's another cluster or maybe Lambda, or maybe ECS, whatever you have. And in addition, kind of all of the capabilities that Federica had covered here that become available as well. So today, I want to quickly summarize what we talked about, right? So we started with simplifying cluster operations. We talked about our choice with Amazon EKS to run our container-based applications. We talked about how it uses VPC CNI for pod-to-pod networking, kind of integrated into the platform. And especially with auto mode, even for a lot of the demos that I showed today, that would have been streamlined because I would no longer have to manage some of those components like the load balancer controller, VPC CNI, Core DNS. They're managed for me. And when we upgrade clusters, those are also upgraded for us. And of course, that means with auto mode, there's other components that are managed as well, things like Carpenter. You don't have to worry about dedicated compute to run those resources either. No dedicated node for Carpenter, no dedicated nodes for your networking components. Kind of moving on here, we talked a little bit about exposing applications externally, right, using the load balancer controller. We talked about creating ALBs, application load balancers, at the layer 7 using the load balancer controller. And at the layer 4 level, we talked about creating individual NLBs by creating services of type load balancer. Kind of further moving down here, we talked a bit about using Istio ambient mesh, enabling us to have layer 4 and layer 7 authorization policies, layer 7 advanced routing, mutual TLS out of the box without disrupting applications, and as well as that interoperability with using sidecars when you need them for specific workloads. And lastly, we kind of talked a bit about VPC Lattice and the new Gateway API, the Kubernetes Gateway API, how it's enabling customers to move and evolve to this new version of networking, and how VPC Lattice, being a VPC capability in Amazon, helps support that. OK, a lot of you might be wondering, how can you continue to learn these things at home? Well, by the way, that first demo I did, that Ingress demo that I did was actually based on EKS Workshop. So that same environment that I showed you with VS Code in the cloud, you can spin that up for yourself. So I highly recommend going through EKS Workshop to learn at your own pace. In fact, I can very quickly just show one thing for you on eksworkshop.com. Some of the things that you'll notice here in the fundamentals section, if we go to exposing applications, the same thing that we showed with Ingress, you can actually set up an environment for yourself and go through it yourself. We talk about things like the multiple ingress pattern. So what happens when you create multiple ingress resources, but you want them fronted by a single ALB? We also talk about IP mode versus instance mode for load balancers as well. So EKS Workshop, a great way, self-paced, to kind of learn everything about EKS. And I really, truly believe that because there's quite a bit of content here, and we're constantly updating it. One thing I'll say is that if you don't want to spin it up in your own account, you can also reach out to your AWS account manager to request an EKS Workshop. And in that QR code, there's going to be a form as well that you can fill out, and we'll reach out to you to help get you set up with an EKS Workshop. Also, EKS Best Practices Guide, now integrated into the AWS docs, a great place to learn about best practices for networking. I know Federica and her team spent a lot of time making a ton of updates to the Best Practices Guide so that it's always kind of the latest kind of optimized setup for networking that we recommend. And you can get a badge as well if you kind of go through one of our courses. All right. That's all we have for you today. Thank you so much for attending our session.
Thank you.